First thing I want to do in this video is just do a quick recap of what we covered the last 2 days. We were talking about ionic compounds, we were writing formulas and naming ionic compounds, and that was always dealing with metals and nonmetals on the periodic table. Some things you had to remember when you were writing formulas is you always had to check the charges to make sure that the amount of positive charge equaled the amount of negative charge so that you were writing the formula for a neutral compound. And we used the crisscross method in order to do that. When you were naming ionic compounds, you just did the name of the positive ion first, such as potassium, and then you would take the negative ion, maybe bromine, but you had to change the ending to IDE, so it would be potassium bromide. But you also had to watch for the elements that we have listed on page 7 that require parentheses, and you also have to be careful with polyatomic ions to make sure that you're identifying those and naming them correctly. That's what we've been working on the last 2 days. What we want to do today is talk about molecular compounds. You're going to love molecular compounds because they're so much easier than ionic compounds to name and write formulas for. So you'll be able to breathe a little bit of a sigh of relief on this one. With molecular compounds, we're dealing with all nonmetals, and you use prefixes to tell how many of each element you have present. With molecular compounds, you don't have to worry about charges, parentheses, or polyatomic ions. It's much easier, requires much less thought. There is something you have to memorize, though. If you turn to page 5 in your packet, I'll give you a minute to get there. If you need to dig out your packet, go ahead and pause the video. So on page 5 in your packet, what you'll see in the middle of the page is a list of prefixes. 1 is mono, 2 is di, 3 is tri, 4 is tetra, and so on and so forth. And you will need to memorize those prefixes. Some you probably already know, and the rest I think you'll easily pick up just through practicing it. So it's not a big deal. So I'm going to turn to a blank slide, and on page 5 I want to just go through the information on there, and then we'll turn you loose to do a little bit of practice. So at the top of page 5, we're talking about binary molecular compounds. And the definition, compounds composed of two different elements covalently bonded. So again, we're dealing with all nonmetals here. When you name them, you use a prefix with the name of the first element, the less electronegative one, if more than one atom of the element is present. And then for the second element, you use a prefix to tell how many you have, the root name of the element, and the ending IDE. So if you look at the examples on that page, N2O, N2 would be dinitrogen monoxide. So if we go ahead and write that one here, N2O, we call it dinitrogen because there's two nitrogens. Monoxide, there's really one oxygen, but you know that we don't write the ones in. So dinitrogen monoxide. The next one down is nitrogen monoxide. One thing to note here is that when we have only one of the first element, we do not use the prefix mono. We only put a prefix on the first one if you have more than one of it, and that's what number 1 above says. If more than one atom of the element is present, you use a prefix. The third example, NO2, is nitrogen dioxide. So again, one nitrogen, two oxygens. And then the fourth one, N2O3, dinitrogen because of the 2, trioxide because of the 3. So just some easy examples to go through to illustrate this idea. Again, the prefixes are there for you to memorize. You'll pick those up as you go. And let's take a look at the practice problems. Okay, so under number 1 in the practice problems, 1A, you have SO3. So we would name that sulfur trioxide. We use the prefix tri here because we have 3 oxygens. Letter B, CF4, we would call that carbon tetra fluoride. Notice that this is all one word, trioxide, tetrafluoride, the prefix tetra telling us that we have 4 fluorines present. Letter C would be NO2. So that's the same as the example above that we did, nitrogen dioxide. And the fourth one, P2O5, we would do diphosphorus. using the prefix here because now we have more than one of this first element, and then pentoxide. Now that brings up a point here. I used pent instead of penta. The prefix is really penta. But when you have those two vowels right next to each other, we typically drop the A and make it just pentoxide, one word. So instead of pentaoxide, we would just do pentoxide. Instead of tetraoxide, we would just do tetroxide. And if you make that mistake in the next few days, I can point that out. That's something we can correct very easily. Let's go on to the formula writing in number 2. Carbon tetraiodide. So carbon, no prefix, that tells me there's just one. Tetraiodide would mean that I'd put 4 iodines. Phosphorus trichloride, so that'd be PCl3, phosphorus and trichloride. Sulfur dioxide, so 1 sulfur, 2 oxygens, and dinitrogen trioxide. Again, we used that example above. That would be N2O3, dinitrogen trioxide. And that is really all there is to naming and formula writing for molecular compounds. When you're naming, don't forget to use the prefixes. When you're writing formulas, you just read the name and use the prefixes. Notice we did not check charges on any of them. We didn't worry about parentheses, polyatomic ions. It was much easier than the ionic compounds. In your packet, if you flip to page 11, I'll give you a minute to do that. Page 11 in your packet says naming molecular compounds at the top. There are 20 of them. So what I'd like you to do is just fly down through those and write the names of those molecular compounds. For each one, you're going to use prefixes to tell how many of each element you have. When you get done with that, please find somebody in the class to compare answers with, and I'll take any questions that you have tomorrow.